Hey guys, let's solve Leetcode 1679 maximum number of keys and pairs. You are given an integer array nums and an integer key. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Return the maximum number of operations you can perform on the array. So let's take the first example. So as you can see in the first example, we can have in the first example you can have these numbers, right? One, two, three, and four, right? So let's take these numbers, right? So we can take let's say we can take one and four, right? Because their sum is we can take one and four, right? Their sum is gonna be five. Let's take and we can take two and three, and their sum is gonna be the sum is gonna be two. So how many operations? How many in how many operations can we remove these numbers in two operations, right? So in one operation we can remove two, one and four. In the next operation we can remove this and this, two and three, right? So we have two operations to remove these numbers. But but in the second example, as you can see, we don't need to remove all of them, right? Because there may be numbers that they don't have any pair to form the sum k, right? So we don't need to remove all of the numbers from the nums array. So for example, in the second example, let's take first let's take we can take, for example, we can take two threes, right? We can take two threes and we're gonna remove them, right? So in one operation we can have two threes and we can remove this three and this three, let's say, and the rest of the numbers cannot form the sum six, right? The rest of the numbers, if we pair up them, they never form the sum k, right? So we only need to have the maximum number of operations is gonna be only one, because we can have only apply this one operation to make the to remove the sum that made up number six. So as you can see, the easiest way of solving this problem is gonna be to sort them, right? So let's take in this the second example and let's sort them. So in the second example, we can sort them like one is gonna be the first one, is gonna be three next, and it's gonna be the third one is three, and we have three here, and it's gonna be four the last one, right? So we can start from this position, and we can start from this position, and we can try and pair up, right? Let's say let's pair one and four, and their sum is gonna be five. So since their sum is gonna be less than six, we have to remove this pointer to this position, and now let's form this the sum of 3 and 4, right? The sum of 3 and 4 is going to be 7, and so 7 is greater than the 6. We have to move it this pointer, the right pointer, to this position. Now we can take these two, right? We can take 3 and 3. Their sum is going to be 6, and we can count 1, right? Our count is going to be 1, and now our two pointers gonna be point to the same position. Now at this point we have to terminate, right? So the maximum number of operations is gonna be one, right? And if we take for the first example also, it's gonna be identical. So one, as you can see, all of the numbers you can see are sorted. So we can take one and four, and let's say we start from here. Let's say we have a pointer here and we have a pointer here, and we start from this position and this position, and we pair up one and four. It's gonna, their sum is five, so we our count is gonna be one, and we will move our pointers to the same to the left and to the right, and now we can take two and three. Their sum is five, and our count is gonna be two, and now they cross each other, then it's gonna be terminated, right? This sorting, using sorting, the time complexity is gonna be n log n, and the space complexity is gonna be of n. So but there is an easiest approach of, but I mean there is an optimal solution, but this one is the easiest way. And so let me explain the next approach. So the next approach is the easiest. The next approach is gonna be the same as two sum, right? If you guys have solved two sum, it's gonna be very easy to solve, right? So if you remember two sum, what we're going to do is we're gonna have a kind of a dictionary, right? Let's say we have let's say one is in our, let's say, in our dictionary, right? So what we're going to do is we take, it's just the to sum approach is going to be like the sum of let's say we're gonna have A and B, right? And their sum is gonna be C, right? So if we know, like, if we know, like, let's say we have given, let's say A plus B is gonna be, since we have given, C is gonna be K, right? So we have given K, right? So that the sum of A and B is gonna be K. So we are trying to find, like, the difference between K, and B is gonna be in our dictionary. So we are trying to find the difference between K and B's in our dictionary. So let's first take one, right? So the difference between, the difference between, let's say the difference between, we are trying to find A, right? We are trying to find this A. So the difference, let's say we take one, right? The difference between 5 and 1 is 4, right? Is 4 in our, let's say, we define our dictionary, like it was initially MPD, right? So can we find for the in here? No, we don't, right? So we add, one in our dictionary with, and its count is gonna be one. And when we are at two, when we are at this position at two, our just we will take the difference between, 5 and 2, and the difference between 5 and 2 is 3. Can we find 3 here? No. So we will add 2 here, and its count is gonna be 1, right? Then at we are at 3, we will check the difference between 5 and 3, right? It's gonna be 2. Can we find 2 here? Yes, we can find, and our count is gonna be 1, right? And now, since we paired this up to since we paired this up to our, the current number with 3, its count is gonna be 0, right? We have, pair it, right? So we can pair it to another number. So since its count is 0, we can remove it from our dictionary. Then whenever we are at 4, we will take the difference between 5 and 4 is gonna be 1. Then we'll, since 1 is here, our count is gonna be 2, and our, since its count is gonna be the count of 0, 1 is gonna be 0. Since 1 is its count is 0, we will remove it from the dictionary. So as you can see, the answer is gonna be 2, right? So the time complexity for this one, this kind of approach, the two-sum approach is gonna be off in, and the space gonna be off in, right? But for the one I have showed you before, the time complexity is gonna be n log n, and the space gonna be n, right? So I'm going to show you all of the two implementations. So let's go to the implementation. So the first approach is gonna be nums. We have to sort nums, right? So we're gonna have right and left pointer, and we're gonna have this one. The right starts from the end of the array, and while, the left one is less than the right one, we can check if nums from the left plus nums from the right, if there is sum is gonna be k. If we have found some k, we can have a count variable, right? The count is just the maximum number of operations. So count plus is equal to 1, else if nums from the left, if plus, we're gonna add nums from the right if this is less than k. If k is less than, if it's less than k, we have to move our left pointer to the right. Otherwise, we have to move our right pointer to the left. And once we have done, we can return count, right? So as you can see, let's see if it works for the test cases. The time complexity for this one is gonna be, time is just, time is of n, n log n of n, and space is gonna be, okay, it says daily. Why? Because we didn't do anything for whenever we found it here, right? So left is gonna be here, and right is gonna be decremented by 1, right? This has to be the case for a TLE. So as you can see, pass for the test cases, and, so we have a space is gonna be of in, right? Sorting is of in space complexity. So let's see if it works for all of the test cases. The first approach. So as you can see, the first approach is gonna be this. So the first approach is gonna be this one, and let's see the second approach. So I'm gonna remove this one, and I'm gonna here to implement using So let's say I'm going to have frequency dictionary. So I'm going to use default dict to count the frequency if they have initial value of zero. So what I'm going to do is I'm going to iterate for numbers for each number in this array. Then if the difference between k and m number is in our frequency, if it is here, what we are going to do is we have found a pair, right? So we can say like we're gonna have a count. Let's say I have a count, the maximum number of operations. So count is incremented by one. So in what we are going to do is we have to decrement frequency of k minus num. That has to be decrement by one. And if the frequency of k minus one is zero, we have to delete it, right? If it is zero, we have to delete it. Delete of this, right? But then else, if we didn't find any pair, what we're going to do is just we add the frequency of num is gonna be incremented by one. Once we have done this, we can return a count, right? So let's see if this works for the test case. So as you can see, pass for the two test cases. Let's see if it works for all of them. So this one is, as you can see, the time complexities. So as you can see, this much of Python users. So guys, if you like this video, please subscribe. It's gonna help me a lot.